Good afternoon, everyone, and welcome to the weekly webinar. I'm Kelly G, your webinar host, and excited to have you all here today. For any physicians that might be watching with us today, happy Doctor's Day. Since 1933, March 30th has been designated as National Doctor's Day. So if you are one, thank you very much for your care and your work to promote health for everyone. If you have a doctor and you have a chance to reach out to your provider, I think they would appreciate that today or any day. And if we have any students or anybody who wants to become a doctor, know that you have a national day in your honor already. So we're happy to have you. I also want to remind everyone that tonight is the world premiere of the KUADRC's movie, Why? Which takes a look at early stage Alzheimer's disease. It is tonight at the Glenwood Arts Theater on 95th near Mission Road. It starts at 6:30. The movie runs for about 37 minutes, and then we'll have time for questions and conversation afterwards. It's totally free to attend. If you want popcorn or other snacks, you're on your own for that. They will be available. And we are going to have, I think, a wonderful time watching this very important show. So hope you can join us. And if you're not in the area or not available, know that we will have other screenings in other parts of the city and around the state of Kansas. So stay tuned to your My Alliance newsletter. With that, I'll remind everyone to stay on mute. I think everyone is except for me at the moment. So thank you for that. Use the chat if you have questions or comments during our program today. And if you need the closed captioning, feel free to click on the CC at the bottom of your screen. And with that, I will introduce our speaker for today. She is Jessica Keller. And Jessica is a registered dietitian and a PhD candidate in the Department of Dietetics at KU Medical Center. She's the coordinator and dietitian for the Therapeutic Diets and Alzheimer's Disease Study and the Ketogenic Diet Health and Longevity Study. Jessica studies the impact of different dietary patterns on health outcomes for adults and older adults. So with that, I know that we are all excited to hear about Jessica's research. So I am going to turn it over to you, Jessica, with my thanks for your being here.
Thanks, Kelly. All right, I'm going to go ahead and share my screen. I'm also going to turn my video off so I'm not staring at my own face. And I'll turn it back on to answer questions. So, all right, let's get started. Everyone seeing my screen okay? Okay, great. Okay, thank you for that introduction, Kelly. So yes, I am a registered dietitian at KU Med. I work on a couple different studies. Today we'll be talking predominantly about the Therapeutic Diets and Alzheimer's Disease Study, or our TDAD study. And I'll be focusing on one of the eating patterns that we're looking at. Today we'll be talking about the ketogenic diet. And kind of just get going. So just a little bit of background. So you're on this Zoom webinar. So I know you know Alzheimer's is a devastating disease. And by and it's only going to get worse. We're an aging country. So by 2050, seniors 65 years and older, they're going to outnumber children. And Alzheimer's is projected to impact over 15 million Americans at that point in time. It's already costing us $3 trillion annually, and that disproportionately impacts those older adults, those seniors and elderly adults. So we can only imagine the burden on our society, especially if we don't get some more efficacious treatments. As we all know, Alzheimer's has no cure. The pharmaceuticals that we have and those investigational drugs we're looking into aren't as efficacious as we'd like them to be. Oftentimes come with a litany of side effects, things like that. So I'll be talking about some behavioral changes that we can certainly make alongside those pharmaceutical interventions or on a standalone basis prior to maybe going down that road. So a ketogenic diet, you've probably heard of it. It's very popular for weight loss these days. But what it is it's a high fat, very low carbohydrate and adequate protein eating pattern. So it is called the ketogenic diet. I just want to take a second to say this is not a weight loss study. it is an eating pattern, and I hate that it's called a diet, but it is an eating pattern, but I'll refer to it as a ketogenic diet. And you may remember the Atkins diet and think, this looks eerily similar. It's not a high protein diet. That's the main difference there. It is a high fat, very low carb diet with just that adequate protein intake. So that's a big difference there, just to start off with. So the word ketogenic itself means that our body is producing ketone bodies. These ketone bodies, there are 3: acetoacetate, beta hydroxybutyrate, and acetone. This is purely for your information. And if you come back to these slides and want to do a little bit more of your own research, you'll see these ketone bodies highlighted throughout the literature. Acetoacetate and beta hydroxybutyrate are going to be the ones that you'll be predominantly reading about, with beta hydroxybutyrate being the most common. Those are the 2 that are circulating in our blood that tissues can use, including the brain. Acetone is a byproduct of the use of these other 2 ketone bodies. So you'll see those throughout the literature, but really what you'll be seeing in a lot of our research and other like-minded researchers' work, the measurements of beta hydroxybutyrate, or BHB. So just a little bit of history. The ketogenic diet goes as far back as 500 BC, when Hippocrates, the father of medicine, notated it in his book on sacred disease, which refers to epilepsy. So what he noticed was those individuals in society that were suffering from epileptic seizures, which obviously there was no medication for those back then. They were shunned from their societies and really had a difficult time procuring food on their own. And so they would go through, especially during these times where they were having these back-to-back epileptic seizures. And through those times, they were doing a lot of fasting, unintentional fasting. But he noticed that the rate and severity of these seizures really decreased when people weren't as well fed. Now, fast forward to the 1920s, a physician named Wilder took note of this, and he was working with youth, so kids and adolescents with refractory epilepsy, which means medically resistant. So the medications available were not working to reduce seizure load for these patients. And so he formulated a ketogenic diet, what he termed to be a ketogenic diet, from these works of Hippocrates. You'll see here it says a 4-to-1 refractory epilepsy, 4-to-1. That ratio, there's a ketogenic ratio. And what that refers to is for every 1 gram of combined carbohydrate and protein that we eat, we have to eat 4 grams of fat. So that's that 4-to-1. Now that's a very restrictive eating pattern. What came along with that 4-to-1 ratio ketogenic diet was a lot of GI side effects. There was a lack of variety in the foods people were allowed to eat to hit that ratio. What came along with that is also low palatability and some instances of growth failure. When we have less variety in our diet, and if it's not as palatable, we're not going to eat as much. We're not getting those micronutrients, those vitamins and minerals that are so key for development. So it was really problematic. So what we're looking at now, and even still, there are people with refractory epilepsy, that, especially young kids, that still follow this 4-to-1 eating pattern. But what we're talking about in our studies is reaching a 1-to-1 ketogenic diet ratio. And that means for every 1 gram of combined carbohydrate and protein that we eat, we need to eat 1 gram of fat. So it needs to be an equal playing field between fat and the combined carbohydrate and protein, and that will induce ketone production. So there's a lot of science going on, but that's okay. We'll get to the food part here in a minute. So just some mechanisms of action. So we know that something's helping in the brain, but how is it happening? Well, first off, it's not noted on this slide, but glucose is the preferred fuel source of the body. Glucose comes from carbohydrate-containing foods. It can cross the blood-brain barrier with a carrier protein, and it does require insulin to be taken up into cells. Ketone bodies are different in the sense that obviously it comes from a completely different substrate. So it comes from fat instead of carbohydrate. But these ketone bodies can also cross that really stingy blood-brain barrier and get into the brain with the use of a different carrier protein, and it does not require insulin or any other facilitated mediator to get into the cell. So how are these ketone bodies, once they get into the brain, how are they helping us? So they're very involved in cellular signaling. So when our cells talk, they're very talkative. They are always talking to one another and saying, you know, something's going on over here, so you need to act accordingly. So when ketone bodies are present, they upregulate the genes that are involved in our starvation response. So obviously, if we aren't getting carbohydrate, which is what humans predominantly depend on for their dietary intake, the body's going to think, oh, we're in famine, we're starving, we better start producing these ketones that we know can still feed the brain and keep us alive. Now, these genes that are involved in that starvation response pathway are actually found to be protective against age-related disease. That includes cognitive decline or neurodegenerative disease, cancers, cardiovascular disease, and you may read about intermittent fasting, and sometimes ketogenic eating patterns and intermittent fasting go hand in hand. But these gene expressions in the starvation response pathway, that's what you're reading about, that's beneficial with that intermittent fasting. So they kind of are born of the same cloth. Another mechanism of action that ketone bodies have that improves health outcomes is that they reduce inflammation. So we all have naturally occurring low-grade inflammation that happens through just biochemical processes that keep us alive, right? But we also have those external forces that also create inflammation, like poor dietary choices, environmental toxins, things like that. So these ketone bodies, the mere presence of them results in improved homeostasis within the cell. That too is protective against those cancers, aging, neurodegenerative disease, things like that, the things that kill us once we get older, the things that we would rather die with than from, right? These ketone bodies also increase systolic glutathione. So I'm sure we've all heard about antioxidants. We love antioxidants. We want to eat foods with antioxidants, but you know, what's going on there? Glutathione is the most dominant antioxidant in our body. So these reactive oxygen species, or ROS, that are they run around the body wreaking havoc, causing damage, causing inflammation. Things like glutathione and ketone bodies themselves can go grab these reactive oxygen species and add an electron and calm them down so they don't wreak havoc throughout the body anymore, right? So increasing that systolic glutathione, the predominant antioxidant in our body, we increase that, and then also just by being a ketone body, decrease the reactive oxygen species themselves, reduces overall inflammation. Ketone bodies also inhibit pro-inflammatory transcriptomic pathways, so those pathways that are involved in turning genes on or off, and those that are pro-inflammatory. So one you may have read about or heard in the literature, NF-kappa beta is a major one that is inhibited by ketone bodies. So looking at how our expression of genes is changed is something exciting that we're doing as well. Ketone bodies also decrease markers for programmed cell death or just cell death. So apoptosis being that programmed cell death, if we hit a certain threshold of reactive oxygen species or cellular degradation, then we're just going to go ahead and the cell kills itself. And then necrosis just being cellular death. So those are all ways that these ketone bodies can reduce inflammation throughout the body, including in our brain and our cardiovascular system. There is a mitochondrial impact. So you may remember back to biology. The mitochondria is the powerhouse of the cell, right? The powerhouse meaning that it creates all that energy that our cells need to keep us going. So as we age, We have fewer mitochondria, and those mitochondria that we do have are less efficient. So our bioenergetic efficiency is depleted over time. And we see that this occurs even more so in people with cognitive decline or neurodegenerative disease. So there's been a big focus on how do we improve bioenergetics in the brain? How do we not only improve the number of mitochondria that we have, but the efficiency of those that we do have? So in these ketone or ketogenic diet studies, we've seen that ketosis reduces inhibitors of entry to the electron transport chain, which is where we produce a lot of our ATP or energy. So to get the substrate into these various complexes throughout this system, there are things that say, no, you can't come in right now. No, you can't come in right now. And these ketone bodies actually reduce the number of those inhibitors so we can get more substrate into that electron transport chain and get more ATP or energy produced to feed those cells, right? The ketone bodies decrease those reactive oxygen species or ROS that we were talking about, and that prevents that programmed cell death that I was describing within those mitochondria. Apoptosis can happen in any cell within the body, but it also has been observed. These ketone bodies have been observed to prevent that programmed cell death in our mitochondria. And then lastly, with mitochondria, ketone bodies, the presence increases citrate synthase. That is an enzyme that is necessary for the biogenesis or creation of more mitochondria. So again, not only are we improving the bioenergetic efficiency, but we are making more mitochondria. In terms of the gut microbiota, those are the bacteria that live in our digestive system below the stomach. I'm sure you are familiar with gut microbiome. That's the total gene expression of those bacteria. So the bacteria themselves are the microbiota. We need to learn so much. There's so much to learn when it comes to the microbiome and the biota. So this is very fresh, and this is part of why we're doing this in the TDAD study. But in looking at a high-fat diet, so a high-fat diet that also includes carbohydrate compared to a ketogenic diet that restricts carbohydrate and produces ketones, shows a different composition of those bacteria in our gut. And that difference has been associated with a reduction of pro-inflammatory immune cells throughout the gut. We have our immune system, it means so well. It wants to help us, but sometimes the activity and action of our immune cells can cause some pretty big problems, right? Autoimmune disease just continues to increase within our population, and we have little explanation for why that's happening. It's very idiopathic for some people, but we have found that reducing these pro-inflammatory immune cells through the use of a ketogenic diet is beneficial without losing out on the benefit of what these immune cells are doing. So these T helper cells that we reduce through ketone production are really involved in maintaining the mucosal integrity of our intestines, and we actually don't see our mucosal integrity degrade, even though we're reducing the amount of those immune cells. So a lot of science there, but just some background. If you're interested in this, there's gobs of literature out there. There's plenty of rabbit holes to go down. So just some main takeaways from that very busy slide. Ketone bodies reduce inflammation and oxidative stress. There's a number of ways they do that, but inflammation and oxidative stress cause aging. And not only do they cause aging, but age-related health consequences. So by reducing those, we're improving health outcomes. Ketone bodies also increase bioenergetic efficiency of those existing mitochondria while stimulating the creation of new ones. And this ketogenic diet, ketone-producing diet, does not have the same impact as a high-fat diet that we read about all the time as being unhealthy. Okay, food, our favorite part, right? So what does this look like? What are we eating? We're eating healthy fats, lots of healthy oils. like avocado oil, olive oil, walnut, safflower, sunflower oils, fatty fish. We recommend fatty fish 3 times a week. Feel free to have more. Not only does it have those anti-inflammatory omega-3 fatty acids, it also tends to replace something that might be higher in pro-inflammatory saturated fats. So it's always got a good place on the plate for us. Nuts and seeds are another great source of healthy fats, omega-3 fatty acids as well, in addition to some fiber. And we love avocado. You know, everyone said, what's the deal with avocado? Well, not only is it a healthy fat, they're chock full of fiber and potassium. There's really not a whole lot of negative things I can say about an avocado, except maybe the price and that, man, they have a short ripe window. What else are we eating? We're eating lots of non-starchy vegetables. So when you hear about a ketogenic diet, you might sometimes hear, oh, bacon wrapped cheese, smothered mayonnaise dipped everything. No, we're still trying to get our fiber in this eating pattern. Fruit, we are not eating fruit except for a 1/4 cup of berries per day maximum. Still want to get those antioxidants, but they do have a lot of sugar. The berries are higher in fiber and lower in sugar. So we'll eat some of those. Some dairy, so lots of dairy products have lactose or added sugars. So heavy whipping cream is a big staple. They do make some keto yogurts now. Certainly there's keto ice cream. It shouldn't be the center of the dish there, but it does exist. And some cheeses. Cheese is high in protein, so don't go on a cheese diet. We still need to be eating lots of fat. We'll use the salt shaker more. Most Americans get our sodium from processed foods. We'll be reducing those. And when we have lower insulin levels, we tend to excrete, or we don't tend to, we do excrete sodium. So we need to use our salt shaker more. Oh, lots is not possessive, but we need to drink lots of fluids. Again, we'll be shedding water. We won't be holding on to as much water if we're not eating carbohydrate. And because we're eating more sodium, we need that water to follow. Things we aren't eating: no grains, no corn, beans, potatoes, pasta, breads. Now I say that there's lots of keto replacement items out there now. There's keto breads, tortillas, certain types of noodles, hearts of palm noodles, things like that. So there are certainly ways to scratch the itch. There's a local lady that makes a fatty head pizza dough that's sold at all the Minsky's. So you know, we certainly want it to be a healthful approach to keto, but understand when there's other things that we want to eat that can still fit. So what does our study look like? It's a 12-week dietary intervention. It's a total enrollment of 17 to 18 weeks. That's because we have a screening period and then we follow up at 4 weeks after the diet. So a total enrollment period of about 18 weeks. It is a randomized controlled trial. So we have 2 study arms. We are comparing this eating pattern to a standard of care eating pattern that's a heart healthy diet. One great thing about our study is there's no real placebo. We believe that following either of these eating patterns will be beneficial for overall health. We'd really like to know if one is more beneficial than the other. So that's a great thing about our study. There are 4 to 6 study visits. We prefer that there be 6, but for those folks that travel in from out of town, we can try to accommodate that by smushing a few of those study visits together. So there's just a listing of time commitment. The study procedures that we do include blood work, anthropometrics, so your height, weight, waist circumference, BMI will track throughout. Dietary assessment, we don't have you write down everything you eat through the study. We have you fill out 3 3-day food records at the beginning, midpoint, and end, so not a whole lot of burden there. We have a pre and post brain scan. You meet with a clinician one-on-one and they'll give you a clinical dementia rating score. A clinician will provide a physical examination prior to diet initiation. We're going to compare cognitive testing before and after the eating pattern, and then we'll have you fill out some surveys and questionnaires. Just some basic inclusion and exclusion. We're looking for 50 to 90-year-olds that have a diagnosis of Alzheimer's disease. Sometimes individuals with mild cognitive impairment fit within our study framework. We do require people speak English and have a BMI of 20 or higher. We don't want to contribute to frailty, and then 350 pounds or less. We do require a dedicated study partner and that the participant live in a residential situation, not in a memory care facility, because we need people to be able to control what they're eating. Excluding people with diabetes that require insulin. If you've had cancer within the last 5 years that required chemo or radiation, cardiac event within 1 year, or a history of kidney stones. Obviously, we need you to be able to follow the diet, so certain things won't work, like veganism. And if you're currently following a ketogenic diet, we'd have to kick you off that for a little bit so that we can see the difference between a baseline and after the diet. We're going to skip a little bit just for the sake of time, but our main outcomes, we're going to look at those cognitive data pre-diet and post-diet. The blood biomarkers we're looking at include cardiovascular biomarkers like a lipid panel, compliance, so we'll look at beta hydroxybutyrate numbers, and then mitochondria health. We'll look at the volume and efficiency of those mitochondria. We're going to look at gene expression before and after. We'll do brain scans before and after, and then we have optional stool samples to look at the gut microbiome that I hope everyone can see how important those data are too. So just some perks for the final is one-on-one counseling with a registered dietitian that I obviously think is the most valuable part of this. I'm kidding, but it is great. You can't get that with insurance. So lots of support from me. We do provide a study supplement. We look at participating in research in general as an extension of care. So it's voluntary, it's free, but you get extra time with that neurology-focused clinician. We compensate. So we compensate for study visits, and we provide a monthly food stipend. We understand that food costs a lot of money. So the total compensation for participating fully in our study is $504. And then you get that wonderful feeling of the reward of participating in clinical trials that can have the potential to move our understanding of this horrendous disease forward. So because of time, I'm going to open it up for questions. We do have some upcoming cooking demonstrations that you might want to jot down or come back and look at the dates. I also have a keto study going on for healthy, cognitively normal adults. So if you're interested in that and are cognitively normal, you can certainly reach out to me about that too. So I will open it up for any questions that people may have. Sorry for talking almost the whole time.
Thank you so much, Jessica. And I heard you mention people might want to go back to the slides. Is that something you would share maybe with
Certainly.
me? And
Yeah.
then if anyone wants to have the slides, you can contact me through the My Alliance email. I think that's probably the easiest way. And then of course, this will be on YouTube in 24 hours or so. And then, we have some questions popping up, Jessica. First, we hear a lot about fruits, veggies, and grains, whereas you and some others say no grains. How do we take in these?
That's a great question. So there's lots of different eating patterns. Like I said, this one is very specific. A ketogenic diet is a prescription diet, right? So if we're eating carbohydrate with all that high fat, then we're really just eating a Western diet that we know contributes poorly to health outcomes. So depending on the eating pattern that you're following, like for instance, you may be referring to like a Mediterranean diet that's oftentimes used for prevention, then obviously you're reducing fat intake. You're imploring that people eat only healthy fats, reducing red meat intake, things like that. Those are different strategies. So really understanding the eating pattern and the goals of your specific eating pattern will help guide you to understand why those recommendations exist. And I know that's a very cerebral answer, but it's the best one I can give without another hour of time to talk.
Sounds good. Okay, and then the next question, Jessica, is any relation to lactate that we talked about last Thursday. So our speaker last Thursday talked about lactate and brain energy, if I'm remembering saying that correctly. Any connection with the keto diet or the TDAD study?
So, our body, it's hard. We tend to learn things in a vacuum where we think that things are happening one at a time over here. If I eat carbs, then I'll be using the citric acid cycle. But it's all happening at the same time, right? On a ketogenic diet, you'll always be eating some carbohydrate. There's no way around that, unless you were doing something like a carnivore diet where you're only eating meat or something like that. So these different metabolic pathways happen in concert in different areas of the cell and throughout the body. So the lactic acid process is also going on. It's just what we're really focused on is making sure that we're producing these ketone bodies that can get up to the brain across that blood-brain barrier and provide additional energy to those neurons and astrocytes. So yes and no is, I guess, the answer there.
Very good. Thank you. Kathy, it looks like, has another question about the age range for the normal cognition group. And did you say it was disqualifying if you had a cancer diagnosis in the last 5 years?
Yeah, so good question. I'll pop this slide up real quick. Since hopefully you had a minute to write down those dates and times. We are looking for 30 to 55-year-old individuals that are generally healthy. So cancer within the last 5 years, if it required chemo or radiation, if it was maybe a surgical removal or something like that doesn't necessarily have a long-lasting impact on gene expression, then we would certainly talk about that on a case-by-case basis.
Very good. Okay. Any other questions? Aha, Kathy, thank you. Kathy says, I thought the speaker last week said that lactate could also be used by the brain instead of glucose.
Certainly, yes, I agree. What this eating pattern focuses on is the production of those ketone bodies. So while we're also producing lactate, we'll be producing ketone bodies. So that's what we're measuring, whereas another study would be looking at the impact of lactate.
Okay, and we have another question, Jessica. A couple of weeks ago, we had Aaron Smith talk about creatine. I don't know if Misa, who asked this question, was there, but the question is, would you tell us about how important the creatine level may be on the senior brain?
That would be a great question for Aaron.
Yeah. So Misa, I hope I'm saying your name correctly. I'd be happy to send Aaron a note and get back to you if you want to. I can look up your address for My Alliance if you're subscribed to My Alliance, and I can get back in touch with you, or you can put your email address in the chat for me, and I'll let you know what I find out. Okay. All right. Anything else from anybody? Thank you all.
I signed on late. Did you guys talk about tonight's showing of Why?
Oh, Amy, thanks for the plug. I did mention
a prize.
Since you asked, yes, a free ticket to the show tonight for you and however many people you want to bring. How about that? So yes, first let me say thank you again, Jessica, for your excellent presentation.
Thank you.
Again, the recording should be available by tomorrow, and I'll get with Jessica to get the slides. If anybody wants those, you can reach out to me and let me know. And then to Amy's very well-timed question, yes, our screening of Why is tonight at the Glenwood Theater at 3707 West 95th Street. That's just a little east of Metcalf. It starts at 6:30, which I think means we're pressing play at 6:30. There aren't any trailers or commercials or anything for this movie. You just go right into the movie. So if you want to see the whole thing, get there by 6:30. First come, first serve seating. I think we have 300 or 400 seats in the auditorium, so you'll probably be able to get your pick, but just in case, you might want to make sure you get there on time. It's totally free. We will have access to concessions if you want to do that sort of thing. The show time is about 37 minutes, and I promise you, I've seen it twice now, you will not feel like 37 minutes have gone by. You'll wish there was more, I promise. And then after the, yes, it is east of Mission. If I said something different, I was just seeing if you were paying attention, Kathy. Yes, it is east of Mission Road. What was I going to say? Oh, we have a conversation afterwards, questions and comments with Michelle Needens, who is the ringleader of this program. Dr. Jeff Burns is in the movie. I believe he's planning to attend tonight. So he's another great resource. I will be there. Lots of reasons we hope you will show up. It is free. And if you can't make it tonight, or if you live too far away, know that we are planning other screenings all over the state and in Kansas City for the rest of this year. If you happen to live in Hanover, Kansas, the movie is coming to Hanover, Kansas tomorrow at the Kloppenberg Senior Center. It is also free. And then we have a showing in Leavenworth next month. And if you get my Alliance emails, you'll have all the information about how to attend any of those screenings. And a big question we've had a lot of is whether it will eventually be available online, like on YouTube or on your computer. And the short answer is yes, eventually. We're focusing on in-person sessions right now because we really want to see people. But at some point, yes, it will be available to watch online. So stay tuned. You'll be the first to know when we know. And I think that is all I have to say for now. Oh, next week. Next week's topic is Heather Gibbs, who is also a dietitian. Based on your feedback, we know you all like to talk about food and eating. So we have Heather Gibbs next Thursday. Her specialty is nutrition literacy. So I don't think she's given me her title yet. So we'll all be in a little bit of suspense, but by Monday, when you get the next weekly webinar information in the My Alliance newsletter, we'll know what her topic is, but trust that it's likely to be something about food. So even more information that I think everybody's pretty excited about. So with that, I think we'll wrap up for the day. Thank you again, Jessica. Thank you everyone for being here. Watch your email for more of the latest and greatest, and happy Doctor's Day. We'll see you next week. Bye-bye.